China and Russia have just made history, a signed agreement to build a nuclear power plant, not on Earth, but on the moon. This isn't just about energy, it's about control, survival, and the next chapter in the space race. But why the moon? And what happens if something goes wrong? In 2024, China and Russia formalized a deal to build a nuclear power plant on the moon by the mid-2030. The goal? To power their joint lunar base, the International Lunar Research Station, or ILRS, planned for the moon's south pole. But this isn't just a dream. It's backed by scheduled missions, like China's Chang'e 8 in 2028, which will test 3D printing, robotic assembly, and even lunar resource extraction. The power station will likely be built robotically without human crews. So how will they build it? The proposed facility could include compact modular reactors or advanced solar arrays. Either way, the challenge is enormous. Construction must survive lunar quakes, temperature swings of over 250 degrees Celsius, and relentless radiation. The moon offers no second chances. If a key system fails, there's no backup crew. It's machines building machines 400,000 kilometers from Earth. A miscalculated landing could destroy months of equipment. Solar flares could fry systems. And if the reactor leaks, lunar contamination could last for decades. There's no atmosphere to dilute the damage. On Earth, radioactive leaks disperse through wind, water, and soil. Emergency teams can respond. The environment helps contain the threat. Weather erodes it, time breaks it down. But on the moon, there's no air, no water, no erosion. Radiation simply settles and stays. A single crack could render an entire crater unusable for centuries. Lunar dust, already razor-sharp and electrostatically charged, could trap radioactive particles and spread them silently on rover wheels, robotic limbs, even astronaut boots. It's not a chemical fire or explosion, it's an invisible death zone that grows every time something passes through it. Rocket landings or crashes could destabilize the reactor's foundation. Dust stirred up during takeoff could spread radioactive particles over vast areas. No rain to wash it away, no atmosphere to hold it back. Micrometeoroid strikes, common on the moon, could breach containment. Astronauts might walk into radiation zones unknowingly. Their suits offer no protection. Radiation, regolith, rocket exhaust, even silence can become dangerous. A radiation leak wouldn't just contaminate a crater, it could poison trust on Earth. The 1967 Outer Space Treaty bans national claims, but has no enforcement. Other countries may see such accidents as reckless, territorial, or even militarized actions. Suddenly, the moon becomes not a scientific frontier, but a diplomatic minefield. The real explosion may not happen on the moon, but in the halls of the United Nations. If nuclear waste enters lunar orbit, it could disrupt future missions, satellites, or even long-range observatories. This is uncharted territory. If China and Russia succeed, they may control lunar energy hubs and polar territory. It's a quiet power grab that could force a new arm's-length space Cold War. Meanwhile, the US and its partners are racing forward with Artemis and SpaceX, but the window is closing. If successful, the station will power science labs, fuel production, and maybe even Mars-bound ships. It could jumpstart lunar industry and deep space missions. As China and Russia set their sights on the moon's south pole, the most resource-rich and possible frozen water, sunlit region, one question hangs in the vacuum of space. Are they claiming the moon's best real estate while the US just watches? The International Lunar Research Station, backed by China and Russia, aims to operate by the 2030s. It's not just a base, it's a foothold. Meanwhile, NASA's Artemis program is preparing to send humans back to the moon, but their mission timeline is uncertain. If one side builds first, will others be locked out? Are we witnessing the birth of the moon's first land dispute? But altering the moon's environment raises new questions. Will heat and energy systems change local surface chemistry? Could infrastructure trigger dust in orbit, interfering with Earth-Moon tides, or eclipsing sensitive scientific instruments? This isn't science fiction, it's the next phase of human expansion. China and Russia have laid the blueprint. What happens next could define not just the moon's future, but Earth's place in the universe. Thanks for watching. If you enjoyed this journey, don't forget to subscribe, like, share, and leave a comment below. Your support helps us keep exploring the universe, one mystery at a time.